Hi and welcome to this tutorial. In this tutorial, I'm going to talk about aspect-oriented programming, AOP for short. Aspect-oriented programming is one of the features that Spring provides. We covered dependency injection in considerable detail in the first part of this course. In this part, we're going to look at aspect-oriented programming. AOP is not just a feature that Spring provides, it's actually a model of programming itself. So before we start with aspect-oriented programming, I'd like to take a quick detour and talk about functional programming. If you've written code in some of the older programming languages like C, you would know exactly what this is. When you're writing code in such languages, you think of a problem and then you break it down into different functions. Each function accomplishes a particular unit of work, and then a function can call other functions, and that's how they talk to each other. And a single program consists of all these different functions, and then they all call each other, and then when the last function ends, that's when the program is complete. So this is the way you would think if you would write code in a functional programming language. You think of them as different functions. The problem here is that if the complex design is involved, then you would have a whole lot of functions and a whole lot of interdependencies between functions. This graph could get really messy. And for some situations, you would get a better design if you would use object-oriented programming. So that's the second programming model. In object-oriented programming, you wouldn't think of functions when you're trying to solve a problem by writing code. You would think of individual entities as objects, and you would write objects that mirror different entities in your problem space. So you would have object A, B, and C, and each object would contain the member variables as well as the methods. So you have encapsulated entities, and you can design more complex code because you have a cleaner design and separation of concerns. Well, this is fine, but then here's a problem. Not all of the tasks that you would want your program to do can be classified into objects. Now let's take, for example, you have a common procedure across different objects. I've taken the example of a log message here. So I want a log message method to be run and to be included in three different objects. Now what does a log message method do? It prints out a message. It's as simple as that, and you want that functionality to be there in all the objects that you are designing in your code. So what would you do? You would have a log message method in your object A, object B, object C. So no matter how many objects need the log message functionality, you would add the log message method in each of those objects. This is not really a good design because you're repeating yourself by including the same method in different objects. So how would you refine this code? One way to do this is to take that method out and create a separate object for it. Of course, you cannot just leave a method floating on its own. You would have to include it inside an object. So you would have a log message method inside a new object called the logger object. And then object A, B, and C would not have that log message method anymore. Instead, what would happen is whenever a log message need to be called, it would reference this logger object and then do a logger object dot log message. It would either have a dependency, so it would create a new logger and then call the method, or this might be a static method and then it would call the method directly. It could also be a parent class, and then you could inherit the log message functionality into each of your objects that need this method. So this is good, but then a couple of problems here. The first problem, now let's say you're doing the design and you want to write a diagram that depicts the relationship between different objects, and you want to know which object is the really important ones, and depending on how they're connected to other objects, you want to know which are the objects that are connected to other objects the maximum. Now, if you write this diagram for a design like this, it's very likely that the most important object and the most connected objects would probably not be your business object. It would probably be this logger object, because every object that needs a logger has a dependency on this logger object. So it is not really a good idea to have this kind of a dependency to something that is not really a part of your business problem. So you have too many dependencies to this logger object, and the logger object is not really adding business value, it's adding something else, it's just doing a support role. So that would be problem one. You have too many relationships to these cross-cutting objects. When I say cross-cutting objects, I mean objects that concern different other objects in your problem domain. The second problem, you still need to have code inside all your methods to make the call. You have removed the log message functionality, for example, and you have put it into a logger object. But then you'd still need each of the methods in your business objects to make a call to this logger object's log message method. So you have removed the method, but you actually haven't removed the code that makes the call, and you cannot remove that because it has to be done. It has to be called and the method has to execute. The third problem is that let's say you want to change in bulk. Say you want to have a different log message method, and you need to make a change in all these different business objects to call that method instead. Of course, you can solve this problem using some more intelligent design. You can have an interface class and then you can plug in the different log implementations. But then if that is not the case, and if you cannot solve the problem by using a common interface, for example, you would need to go to each of those classes and you need to make the code change. Now, why are these significant problems? These are significant because this whole concept of having a cross-cutting object is very common in the software design. So you can have this in a lot of situations where you have cross-cutting concerns. You have some functionalities that need to be used by different objects, and they may not be a part of your problem domain. It could be infrastructure related, it could be security related. So these are some of the common cross-cutting concerns that you would see in a normal real-world application. Almost every major application does some kind of logging or the other. Transaction and security, I would say, are necessary evils. You will have to implement them depending on your business problem and the number of users. So since this is a common problem, there are ways to deal with it, and we can use aspect-oriented programming as one of the really elegant ways to solve this problem. Okay, so let's see how things change with aspect-oriented programming. So you would have what are called as aspects. So you have removed the common functionality in objects A, B, and C. Instead, what you do is you do not create a new class for logging, you create a new aspect for logging. So it's actually a class, a special class, I would say. We'll look at how aspect is different from an ordinary class down the line, but for now, think of it as a class with special privileges. So you have a logging aspect class defined separately from your normal classes and objects. So similarly, you can have many aspects. You can have a transaction aspect if you want to implement transaction-related cross-cutting concerns. Now you might ask, how is this different from having a separate object? You would have an object for logging, instead you're having an aspect for logging. Now how is it different? The difference is in the second point here. After creating these separate aspects, what you do is you do not reference these aspects in your code. Say you want to have some methods in object A, B, and C to use the logging aspect and the transaction aspect. If it were an ordinary class, what you would do is you would have to instantiate an object of the class and then call the methods. You wouldn't do that for aspects. What you would do instead is you would define a configuration, the aspect configuration, which tells which objects and which methods these aspects should apply to. So this is what is different from the traditional object-oriented programming, where you would take these common functionalities, create a separate class, have objects, and then reference those objects inside your objects which actually need those functionality. Instead, what you do is you have aspects, and then you write configuration, which tells which aspect applies to which methods of which classes. So this is something that Spring helps us with. Spring helps us with dependency injection. You say, okay, my object is dependent on these objects, and then you tell Spring to inject these dependencies. So Spring also helps us here. Spring says, hey, I already provide your dependencies for you. You tell me what aspects are needed for which methods, and I will make sure that those methods are also called. So what would happen is, now let's say, for example, I have a particular set of methods in all these objects, and I want a logging aspect method. Say I have a logging method over here. I want this method to be called just before each of these methods I'm concerned about runs. So say I have 5 methods here, I have 2 methods here, and I have 1 method here for which I want the logging method to run just before those methods execute. So what I would do is I'd write the configuration over here and say, for all these methods, make sure that the logging method runs whenever those methods are called. So this is something that I can tell Spring to do, and Spring will make sure that the logging method is called just before those methods that I've configured here are executed. So before is just one of the ways in which you can apply aspects. This is similar to, let's say, for example, you have servlet filters. You can configure filters to run before each and every call to your servlet executes. You have similar examples like this. Those are not aspects, but you can think of it in this model. Let's say, for example, struts interceptors, or for example, triggers in databases. Say you want to do an insert, you write triggers so that whenever that insert happens, there is also this other functionality that gets executed. So aspects are kind of similar to that. You can have methods inside aspects that get executed just before particular methods in your objects run. So you can have different levels of configuration. We'll have a look at that later, but think of it that way. You have separate pieces of functionality that are configured to run before some other pieces of functionality run, and they are not configured in the code. They are actually separate configuration files, and since they're all running inside the Spring container, Spring makes it easy for that to happen. Spring reads this configuration, and whenever it senses that those methods are called and those are executed, just before those executions happen, these configured aspects are executed first by Spring so that your configuration is achieved. So with this model, some of the advantages are obvious. Now let's say I want method ABC here to have logging, and I want method DEF not to have logging here. So what I can do is I can configure ABC, and I can say for method ABC, run the logging method, and for DEF, I don't have any configuration here. Now down the line, I want to change this configuration. I want to say, I want to have the logging method run for method DEF also. So in that case, I don't have to go to this object and change the code. I don't have to write the call to the logging method here. Instead, what I do is I go to the log aspect configuration and say logging aspect needs to run for method DEF also. So in that case, whenever the method DEF executes, the logging method is also executed just before the method runs. So this makes it very easy for us to add and remove and make any changes as such without making changes to the code. You can make changes to the aspect configuration and have these aspects apply to different points in the code. And this solves some of the problems that we've noted earlier. If you want to make bulk changes, you can do that as well. Just with a few lines of aspect configuration, you can have a particular aspect apply to a whole lot of methods in a whole lot of places in your application code. And aspects get their true power by wrapping around your target methods. So let's say you have an execution of the target method. You can configure an aspect to run before or an aspect to run after your target method, so that if you configure it this way, this code will get executed, and then your target method gets executed, and then another piece of aspect code gets executed. So you have a lot of flexibility here. We will have a look at all the different configurations you can achieve with aspects in the next set of tutorials. So this is something that you can keep in mind. You can have different flows of control, and you can configure them using aspects. So what are the steps we need to take in order to write aspect-oriented programs? So the first step is to write the aspects. We need to identify what are these cross-cutting concerns, and we need to write them as aspects. And the second step, configure where these aspects apply. So We talked about logging. We can select particular methods for which the logging method runs just before those methods execute. So that's the configuration that I'm talking about here. So these are the only two steps you need to do. First, write the aspect itself, and then configure to what places in your code these aspects apply. Okay, now that we have covered the concepts of aspect-oriented programming, in the next tutorial, we are going to actually write some aspects and we are going to configure them, and we're going to make Spring execute those aspects. So I hope the concepts here are clear. I'll see you in the next tutorial.